You're watching the Weiss Channel. Da-da-da-da-da-da.
Yeah.
So, today we are doing what's called arrangements of repetition. Okay? Have you ever wondered, maybe you have, maybe you haven't, how many license plates can be made? Like, after a certain number, like you see letters and numbers on license plates. Would you agree that there's a limited number that you can have on the license plate? I mean, there's only so many letters and only so many numbers, right? Well, what if a license plate had 3 letters and 3 numbers? Let's say the X represents a letter and the Y represents a number, okay? How many letters are there in the alphabet? 26. And how many numbers are there from 0 to 9?
9.
Is it 9 or is it 10? Including the 0.
Oh, he is.
10, right?
That's what I said.
So, how many possibilities are there for the first letter in the license plate? 26, right? So how many possibilities are there for the second letter in the license plate? 26. How many possibilities in the third letter? 26. So it's going to be 26 times 26 times 26. Times, how many possibilities for the first number? 10. How many possibilities for the second number? 10. How many possibilities for the third number? 10. So on your calculator, you do 26 times 26 times 26 times 10 times 10 times 10. If you do 26 times 26 times 26 times 10 times 10 times 10, it's a lot of multiplication, right? Am I trying to tax you?
It's not even tax season yet.
No.
When is tax season? Dang, brody, these y'all be bro, I can't even get no tax value.
17,576,000.
You gonna be his user job.
Okay. Now,
That's it.
to be less taxing, right? Would there have been a faster way I could have done this? Yes, I could have done 26 to the third power times 10 to the third power. That would be less taxing during this non-tax season, right?
Yeah,
Okay.
that's what I like to hear.
All right.
Bro.
Over here, okay, in the second problem, how many different telephone numbers in the form AAA, BBB, CCCC can be made? Let's assume for the moment that none of the first 3 numbers could be a 0. Now, you know that the first number in an area code can't be 0, because if you hit 0, you just get the operator, right? But just for this problem's sake, can we assume that none of the 3 first numbers can be a 0?
Right.
So how many numbers for the first number are possible?
9.
9, right? There's 10, but if you take away the 0, that's 9, right? So 9.
Whoa. But 0 don't count as numbers.
0 counts as a number. It's a number.
But it's not 1. No, you take away
No,
1.
2 isn't 1 either.
2 is 2.
All right.
0.
So 0 is a digit. It counts, right? How many digits for the second number, assuming we can't use 0?
1.
9. For the third one, assuming we can't use 0? 9. Now, how many for the rest? Because you can use 0. All of them are going to be what? 10, right? Okay, so let's do 9 to the third power times 10 to the 7th power, which is a 1 with 7 zeros. So I'm going to do 9 to the third power times a 1 with 1, 2, 3, 4, 5, 6, 7 zeros. Gives me 729 and 1, 2, 3, 4, 5, 6, 7 zeros. 729 with 1, 2, 3, 4, 5, 6, 7 zeros.
You use them, I think.
Okay? So the number of possible phone numbers is going to be 7,290,000,000. Okay? And the next one, the question is, how many different codes can be made of the form XX, YY, hashtag, or number sign, or pound, where X represents a letter, Y represents a number, and hashtag represents a special character, which is going, for this case, hashtag is going to be either exclamation point, the @ sign, the number sign itself, the $sign, or the % sign. How many signs are there? 1, 2, 3, 4, 5. Okay. Once again, how many letters are there in the alphabet? 26 times 26. How many digits? 0 through 9? 10.
You said 27?
I got 26.
Oh.
And how many of these special characters do we have here? 5 times 5. So you're going to do 26 times 26 times 10 times 10 times 5 times 5 equals 169 with 4 zeros. Or 1,690,000. Okay? Over here, how many different passwords can be created in the form of XX, YYYYYY? Right? Same thing that we've been doing all along. How many letters in the alphabet? 26 times 26. How many numbers? 0 through 9? 10 times 10.
What do you mean?
What do I mean?
By 0 to 9.
From 0 to 9, isn't that 10 digits, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right?
Where did you get 0 to 9 from?
I'm telling you, and it's written in the problem, okay, in front of you actually. If you look at number 1, for example, it says, how many license plates can be made of the form XXX, YYY, where X is a letter of the alphabet and Y is a number from 0 to 9. Do you see that there in number 1? Okay? So that's what I'm talking about. In this entire paper, that's what I'm referring to. If I say Y is a number, please assume that it's between 0 and 9. If I just say Y is a number, please assume it means 0 to 9. Okay? So what is that? Well, again, 26 times 26 times 10 to the 6th power. Wait. $676 million. Okay?
So why automatically 10?
On today's paper, yes, Y will automatically be 10. You've been watching the Weiss channel. Da 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 da.